this I was saying that this characteristic and of error and biases of single difference are represented for the first. अच्छा, इसमें नहीं arrow इसमें जाएगा ना. Okay, pointer लेना पड़ेगा. So I was saying that this between receiver error, which is eliminated, the satellite clock, the error which is eliminated is represented in the left column. So the satellite clock is eliminated. Then you have ephemeris, which is reduced. So nothing is explained as completely eliminated. It is only mentioned as a reduced. Then you have receiver clock, which is not removed between this single difference. Receiver clock is there. Then you have ionospheric, which is reduced, tropospheric, which is reduced, and then you have cycle ambiguity. And this noise is increased by square root 2. Okay. Once in a while, we just also see this battery of this. 90%. Okay. So, so with this, any questions on this table? Okay, so we move to double difference. In the double difference figure, just imagine you have two satellite and two receivers are there. See, the double difference is difference of two single difference. So in order to form difference of two single difference, what you need? You need two receiver and one satellite as one pair, then two receiver and one satellite as one pair. So in this particular figure, you could see I and J are the two satellites, okay, and A and B are the two receivers, okay. So A and B are the two receiver, and you are forming first pair of single difference between A, B, and I. Then second pair of difference single differences between A, B, and J. So it is the for 2 points A and B and two satellite J and K, difference of two single differences. Okay, and it is used to so-called the compute, reduce the satellite clock and orbital errors. Just feel this figure. Okay. So it is usually added by the final carrier phase GPS solution, and relative GPS can also use this approach. So in first single difference, what you have minimized or eliminated You have eliminated the satellite clock. अब आप लोग कहेंगे सर सैटेलाइट क्लॉक एरर तो सर नोन होती है, उसको एलिमिनेट कर लिया तो क्या फायदा हुआ? That can also be a question, that since satellite clock error is already known by navigation message, so if we have removed that by single difference, then what's the benefit? So that is why I'm saying single difference observable are least used, because they do not eliminate majority of the extra unknowns which we have to estimate in the process. But in the case of double difference, one objective which is we are fulfilling is that we are eliminating the receiver clock error. How? Let us see. So you have this model for double difference, isn't it? You can see that. You can see that model. There are two single difference equations are written. Most of you could quickly follow, but some of you may need time to follow the same. So this particular equation is written for in this attempt that two single difference are written, and we are trying to subtract these two equations to make a double difference observable. One more thing which you need to understand is that your observable is again the same, that is carrier phase observable. That is the first observable you achieve by doing positioning. Then gradually what you need to do is that you try to form these alternative observable like single difference, double difference by the same principal observable, with one purpose, just to eliminate those errors which are common to it, plus that will help you in one purpose, that would give you lesser unknown to be estimated. Imagine this carrier phase observable equation, principal carrier phase observation. You have three XYZ, then set receiver clock error, then ambiguity. So you have five unknown. But once you try to form a double difference observable, I hope you are writing this equation. If you are writing it, that is much more beneficial, because you can pick it up the contents very quickly. So phi abjt is the single difference observable between AB and J. Then 1 by lambda rho abj, that is the geometric range between A and B receiver with respect to J satellite, plus ambiguity, combined ambiguity after single difference for with respect to jth satellite, plus fj into delta ab, which is combined receiver clock errors. I am repeating these statements because you must also say, when you are writing any, or when you are speaking on any forum, you should also speak the technical terms for individual component rather than saying phi abj, rho abj. You should also speak the name of it. Similarly, I do not ask anyone, or I do not want everyone to, come one by one and say it. Just repeat it on your mind. What you will say for AB, phi ABK, for what you will say for rho ABK, what you will say for N ABK, and rho delta ABK. So that is important, that you should understand that these are the two primary carrier phase observables. Okay. Any questions? Okay, so case one, if you have same frequency, that means between AB and J, you are observing on F, let's say. So F, J and Fk are same, because you know that if you are observing on L1 and if you are observing on L2, when you differentiate, there will be residuals. Now complete error would not be there. Class. And this phi abj and phi abk are differenced in the first line, first block of equations, and then on right hand side when you differenced it, only owing to this term, that is carrier frequencies are same, you will get this combined term. Just observe it. Is it clear? Any questions?
Sir, what is phi here?
Where? First equation.
Yes, sir.
अब बताइए कि phi is your single difference observable. अगर आप phi abk को फिर से ओपन करेंगे तो phi abk क्या है? अगर आप स्टेप बाय स्टेप नीचे आए तो phi ab jk जो ये है वो है phi abk माइनस phi abj, और फिर phi abk क्या है? ये देखिए इधर phi bk माइनस phi ak. एक एक स्टेप जंप करके आइए. Phi abjk, this is the double difference observable, but come back to this equation. Phi abjk is opened up as phi abk minus phi abj. फिर तीसरे पे आइए, तीसरे ब्लॉक में फिर देखिए phi abk को ओपन किया phi bk minus phi ak. So this is the raw observable, which is written in the third block. This is the raw observable that has been received at individual receiver. Then you are trying to form with respect to pair the so-called first single difference, then followed by double difference. I will suggest that you should write these equations once, all of you. I'm giving you a moment.
So I think it's fine. Now the case of double different frequency is you need to understand before we are putting up. So we will again rewrite those equations which were differentiated in the previous case. So here you have the phi aj plus fj multiplied by rho j, sorry, delta j is equal to 1 by lambda rho aj plus naj plus fj into delta a. So this is for a receiver with respect to jth satellite. Now again, the bth receiver with respect to jth satellite, but on f different frequency, let's say. So this fj and this differentiation which we are making it here, where fj is not equal to fk. So for that moment, what we can assume, let's say we can multiply this into linear units. Then once it is multiplied, you will have this term called phi b, capital phi, which is multiplied by lambda. The upper equation is lambda multiplied by lambda. And once you multiply the lambda with respect to each equation, if it is same, you can differentiate it. The case one will remain prevalent. But if the difference is there in the frequency, let's say fj, both fj are not equal. Fj is equal to not equal to fk. So what will happen? You will rewrite this equation. I think there is one problem which I observed this slide. The second line should be written with respect to k, but in fact it has been written with respect to j only. Yes, quickly I got it. This equation, which is the second equation in the first block, it should have been fk in the second one, but it is written as
Sir,
oh, okay. No,
we
it's
should
okay.
have two more
It is
equations.
between jth satellite, the two equations are written. I forgot. Okay, it is okay. It means it is the equation of individual receiver with respect to jth satellite. It is written. Then it has been multiplied by lambda to convert it into the linear unit. So this phi abj is equal to rho abj plus lambda j n abj plus c phi ab. This is the single difference equation in linear units. Please remember, the second block equation is the single difference equation, but in linear units. When I say linear, that means the multiplication of your carrier phase observable with the corresponding lambda has been done. Okay, yeah. So the second equation is the equation for single difference, but in linear units. So correspondingly, you would also have the phi abjk. The moment you do the second equation, you can see that it is phi abk minus phi abj. This is the double difference equation, which is written as the difference of two single difference, that is phi abk minus phi abj is equal to rho abk minus rho abj plus lambda k n abk minus lambda j n abj plus rho abjk plus lambda k nabk minus lambda j nabj. Now what I want is that you individually follow from above. From above means if you just see this equation, that is phi abj is equal to rho abj. So if you write the same equation for kth satellite, it will be phi abkt is equal to rho abkt plus lambda k nabk plus c delta ab. So when you differentiate it, obviously this right hand term, which is the receiver clock term, will be gone, but you would be having phi abk minus phi abj, the first term, which is rho abk minus rho abj plus lambda k nabk minus lambda j nabj plus rho abjk plus lambda k nabk minus lambda j nabj. Any problem in this equation? Just see it. Any question? You just write this equation in your note sheet. Any questions you can ask? Any small question also you can simply ask. That is how you are writing this equation. What is this? What is this? Again, I am reiterating that these double difference observables are prepared from raw observable itself. The reason is very simple. Our whole single objective is to get the position. Okay. Any, no doubt. All of you have written the equation, isn't it? So let me just move it. See,
Sir,
the objective of this particular. Bhagat, you want to say something?
sir, why lambda is different?
Your audio is not coming to me.
Yes, sir. Sir, why lambda can lambda j? Satellite use the same frequency module carrier wave. So, like the two satellites are why lambda lambda. Hello, sir.
Hello, Bhagat.
Yes, sir.
You want to say something?
Sir, like there are two satellites JK, then why we choosing lambda differently?
That
Because
is, okay. Okay. First, please tell me. Have you listened the whole discussion that I've told you?
no, sir, not the last class, sir.
Then not last class, nahi. Just before what I'm speaking.
Uh, मतलब, up to the slides.
Yes.
Yes, sir.
Okay. So this is the case for different frequencies. Now, ऊपर देखिए आप, case 2 is for different frequency.
But sir, satellites use the same frequency, na? Like
अरे भाई
1.5.
सेटेलाइट तो सेम दे रही है, लेकिन सेटेलाइट के पास दो फ्रीक्वेंसी है ना, L1 L2। तो ये बता रहा है कि हो
Okay,
सकता
okay,
है
okay.
एक रिसीवर L1 पे काम कर रहा हो, एक रिसीवर L2 पे काम कर रहा हो। समझ गए
Yes, sir.
सभी लोग?
Yes, sir.
Okay, so let me just move in the next slide if everybody is okay. Now this whole equation is rearranged. Okay, this whole equation is rearranged. Just follow one by one. So you have phi abjk is equal to rho abjk plus lambda k nabk minus lambda j nabj. But we are introducing two terms. Although the this introduction will not change anything in this equation, but this is lambda k nabj plus lambda k nabj, so it will be again 0, but we have introduced, just like we have done in many times in our 12th or 10th level mathematics. Some rearrangement will be conducted here. So now you could see lambda k is same, so lambda k nabjk is completed here. So first is rho abjk, then lambda k nabjk plus lambda abj, within bracket it is written as lambda k minus lambda. So this is called as the bias. It is called as the bias of single difference bias. It is above equation differs from double D equation by single difference bias. Unknown nabj can be estimated by single point positioning with an accuracy of about 10 meters, that is corresponding to 50 cycles of approximately 20 centimeter wavelengths. If the wavelength difference of the two carrier corresponds to 0.00035 cycle, which is typical for GLONASS carriers being separated by one carrier number, then the resultant bias is of 0.02 cycle is obtained. Thus, for a small frequency difference, BST acts as a nuisance parameter. For larger difference, iterative processing is proposed. In the first step, only satellite with the small wavelength difference are considered. So this objective of introduction of this so-called bias term is introduced in this case where you have both frequency which is different. This is the table for double difference. You can go through it. Just see one by one. That is satellite clock. You could see in double difference it is eliminated. Ephemeris, that is orbital characteristic or orbital errors, which is reduced. All these depends on the receiver to satellite difference. See, whenever your receiver are within 80 kilometer or 100 kilometer or range, the all possible errors are highly correlated. But if your receivers are beyond 200 kilometers, then the error which is common to both them is very less, or the chances of spatial correlation between the error is very less. Receiver clock eliminated, ionospheric reduced, tropospheric reduced, cycle ambiguity again it is not removed, and noise is increased by 2. Similarly, if you see this first pair is for receiver to satellite that we are doing, isn't it? Then there is another double difference which can be done for receiver but epoch, like lambda, phi abj t1, phi abj t2. You understand? This is the receiver epoch. So in that, satellite clock eliminated, ephemeris reduced, receiver clock देखिए आप यहाँ पे नहीं remove होगी. Why? If phi abj t1 and phi abj t2 की इक्वेशन आप लिखेंगे तो क्या होगा? Every epoch will have a different clock error, तो वो eliminate नहीं होगी. But at the same epoch अगर आप पेयर बनाएंगे तो रिसीवर क्लॉक एलिमिनेट होगी. ये समझ में आ रहा हो फैक्ट तो बताइए, नहीं तो फिर इसको फिर से रिपीट करें.
सर एक बार और.
हाँ, मैं फिर से कह रहा हूं, देखिए रिसीवर इपॉक ऊपर हेडिंग पड़ी हुई है एंड रिसीवर सेटेलाइट. सो व्हेन यू हैव receiver as two receivers are there and you are forming with satellites pair, तो lambda phi the phi abj minus phi abk, इस प्रोसेस में क्या होगा, आप ap एक ही इपॉक पे दो डिफरेंस बना रहे हैं. But the second is saying, what if you do not choose the same the first column, if you obtain the double difference for second case, like between receiver but at different epoch. तो एक सैटेलाइट तो आपकी मान लीजिए कॉमन डेटा दे ही रही है. यू हैव ए वन कॉमन सैटेलाइट टू व्हिच इज सेंडिंग डेटा टू बोथ स्टेशन ए एंड बी. सो phi abj t1, phi abj t2, जब इनको डिफरेंशिएट करेंगे then your receiver clock will not be eliminated, क्योंकि एवरी इपॉक पे क्लॉक की वैल्यू बदल रही है. वो माइंड योर कैरियर फेज इक्वेशन वेयर यू हैव रिटन c delta t1, c delta t2, c delta t3. Why? Because if you are taking 4 satellite for 3 epoch, the 3 unknowns would also be coming for carrier phase. They will not be same. So the 3 unknowns would be coming for receiver clock error. They would not be same. Why? Because receiver clock has having every epoch a new error value is coming. अब आप तीसरे वाले कॉलम को देखिए, इट इज सेटेलाइट इपॉक, मतलब बेस एक है आपका, दैट इज फाई ए जेके T1, फाई ए जेके T2। तो ये आपका डबल डिफरेंस पेयर के लिए सिंगल रिसीवर का यूज हो रहा है, इसीलिए ऊपर है सेटेलाइट इपॉक। तो उसमें देखिए रिसीवर तो एक ही है, ठीक है, लेकिन सेटेलाइट क्लॉक रिमूव नहीं होगी क्योंकि वो भी दूसरे इपॉक पे चेंज हो जाएगी। Any questions? अब आप तीसरे डिफरेंस पे चलिए, इसके लिए क्वेश्चन आप बनाइए पहले। थर्ड डिफरेंस और ट्रिपल डिफरेंस इज नथिंग बट difference of two double difference at two different epoch. So difference of double difference at different epochs T1 T2। तो अब आप पहले अपनी नोट शीट का यूज करके दो डबल डिफरेंस का इक्वेशन लिखिए और सभी लोग मुझे स्क्रीन अपनी अपनी दिखाइए, मतलब नोट शीट पे लिख के फोटो खींच के भेजिए सभी लोग। दिस इज अ शॉर्ट असाइनमेंट, आई एम गिविंग यू ओनली 5-10 मिनट्स। आप इसमें क्या करिए, दो डबल, जिसको स्टार्ट से स्टार्ट करना है दे कैन स्टार्ट फ्रॉम basic raw observable, then form the single difference, then form the double difference, then form the triple difference, but quickly do it. I'm giving you 10 minutes.
सर यहाँ पे हम सेम फ्रीक्वेंसी यूज करेंगे?
हाँ, क्या बोल रहे हो?
सर यहाँ पे हम एफ आई और एफ के की वैल्यू, जो एफ जे और एफ की वैल्यू सेम लेंगे?
हाँ, यहाँ पे आप सेम लीजिए, हाँ यहाँ सेम लीजिए। हाँ आलोक ठीक है आपका। और लोग भी भेजे भाई। हाँ बस
मैंने
इसी
भी
के,
भेजा है।
हाँ इसी के नीचे बस आपको सुमित यही लिखना है, और आलोक आपको भी फाइव ए बी जे के T1 T2, instead of writing in a different fashion should write phi abjk t1 t2 is equal to 1 by lambda rho abjk t1 t2। ठीक है, गुड। ठीक है भगत आपका ठीक है। वैली शेट्टी, कैन यू लिसन मी? हेलो।
यस सर।
भाई आपका आया नहीं अभी तक, सेंड नहीं किया आपने?
सेंडिंग सर।
प्रवीण ठीक है आपका? ठीक है, ओके। किसी का आउटपुट आया? देखिए, दिखा तो हम देंगे तुरंत, नेक्स्ट स्लाइड है, बट दैट विल नॉट गिव यू इनफ curiosity, is that to how to achieve that right solution. If you have anything, just you can explain it to me.
सर आपने कुछ और पूछा था क्या, कोई क्वेश्चन दिया था क्या? सर आवाज ही नहीं आई सर, कोई आवाज नहीं आई आपकी।
अरे भाई, मैंने कहा था डबल डिफरेंस के लिए आप इक्वेशन लिखिए और बताइए कि कैसे एनजी और एनटी का रिलेशनशिप आप बताएंगे, ये मैंने पूछा था।
सर आवाज नहीं आई थी आपकी कोई भी।
तो आप लोग को आपने बताया नहीं, मैसेज भी नहीं किया।
सर हमें लगा आप बाकी स्टूडेंट्स का और वेट कर रहे हैं।
नहीं 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 भाई, static relative positioning for single difference. I have written this equation. Have you listened this statement which I have explained this part?
नो सर।
Okay. So this phi abj is equal to 1 by lambda rho abj plus n abj plus fj into delta ab. Is this an equation for single difference? So how many satellite? One satellite. J. How many receiver? Two receivers. So that two receiver and one satellite at one epoch is giving one equation, that is nj into nt. So nj is 1, nt is 1. So this is one equation. How many unknown? 3 plus 1 plus 1, that is 5. So that's unfair. So always observable should be more than the required, your so-called unknown. So nj into nt should be greater than equal to 3 plus nj plus nt. That is the equation for single difference I have asked. Now, having said that, just similar to this, you write the equation for double difference on your note sheet, like phi abjk plus 1 by lambda rho abjk plus n abjk, and then you write the equation of nj into nt. Considering in the mind, the hint is you first ask to yourself how many satellite, and then how many equation of double difference are available, how many epochs and how many equations are available, and then you can write like that. This was I was asking. I'm giving you another 2-3 minutes. You just focus on the content and try to form. First, you write the double difference equation, then ask this question to yourself: how many satellite and how many equation, how many epoch and how many equation. That's how you will arrive at S nj into nt. हाँ भाई, तो इतना समय नहीं लगना चाहिए। क्या आया?
Sir, for same frequency one, NT should be greater than or equals to 9 plus NJ NK upon NJ into
9
NK.
9 कैसे आ जाएगा भाई? 9 कैसे आ जाएगा? 9 कैसे आ जाएगा? 9 कैसे आ जाएगा?
जब रो ए बी जे के टी होगा सर, वहां पे रो ए बी जे के लिए 3 अननोन्स एंड रो के ए बी के लिए 3 अननोन्स। सर यहाँ 6 होगा क्या?
6 भी नहीं होगा, 3 होगा।
सर
मैं कह रहा हूं यहां पर भी 6 क्यों लिखा जाएगा जब रोवर के अननोन होते हैं ना, बेस के तो नोन होते हैं, तो 3 केवल रोवर के आएंगे।
ओके सर।
देखिए देखिए एनजे -1 क्यों? 2 सैटेलाइट थी, एक इक्वेशन आ रही है। एनजे -1 इंटू एनटी इज इक्वल टू और ग्रेटर देन इक्वल टू 3 प्लस एनजे -1। क्यों? 2 सैटेलाइट थी, एक ही इक्वेशन आई। So it is ni, sorry, nt should be greater than equal to nj plus 2 divided by nj minus 1. So that is giving us to nj, for nj is equal to 2, nt should be 4, or for nj is equal to 4, nt should be greater than equal to 2. तो जब 4 सैटेलाइट होंगी तो 2 इपॉक पे काम चल जाएगा। That is to avoid linearly dependent equation when forming a DD. A reference satellite is chosen and against which the measurements are formed. Suppose you have 3 satellite, so one would be common to both pair of double difference. So for example, you have satellite 6, 9, 11, 12 and 16, and with 6 as a reference, so pair would be 9, 6, 11, 6, 12, 6 and 16, 6. Okay. Similarly, for triple difference, for 2 satellite and 2 epoch, you are getting single equation. That is nj minus 1 into nt minus 1 should be greater than equal to 3. That gives us that for nt should be greater than equal to nj plus 2 and nj minus 1. We have for 4 satellite, you have more than 2 epoch. So with this, we stop here. If you have any questions, I'll just upload this slide and you can go through the content. I'll share this slide on your MS team also. Okay.
But this is there.
This one is there.
Yes, sir.
Okay.